before you start the presentation, don't forget to like and subscribe below. My name is Nur Adila.
And my name is Nur Fatah binti Zukri. So, the question given to us is, a commonly used lens coating materials is magnesium chloride with refractive index n equal to 1.38. What thickness should a non-reflective coating have for 550 nanometer light if it is applied to a glass with refractive index n equal to 1.52? Given a hint for us, non-reflective coating is destructive interference. Okay, so the figure for 2.A should be like this. We have thin film here, which is magnesium fluoride, and the refractive index is 1.38. And glass block, the refractive index for glass block is 1.52. So the incidence ray will enter the thin film and it will refracted and also reflected. It will refract into the glass block and reflected again into the air. So the question asks us to find the thickness of the thin film.
So for this question, we can use two equations. 2nt equal to m lambda and 2nc equal to m plus 1 over 2 lambda. So we use the second equation because this is in phase coherent source and it is destructive interference. So we use the 2nt equal to m plus 1 over 2 lambda. So and we substitute with 1.38 because we want to find the thickness of the coating material. And then the m we substitute with 0 because we use the minimum fringe. And for the wavelength we use the 550 times 10 to the power of 9. So negative 9. So when we solve the equation, we get t equal to 10 times 10 to the power of negative 8 meter. So when we change into the nanometer, we get t is equal to 100 nanometer. So that's the answer.
Hello, I am Nur Hidayah.
Hello, my name is Nur Carmela Bukade, and we are from TMS0334 group 29.
So for question 2B, the question give the situation about the A wedge, how the A wedge is formed. A piece of paper or another material are put between the two glasses or two different material. When the piece of paper are put in between this, the thickness are exist. So basically, for this question, they ask us to find the thickness. How to find the thickness? First, the incident ray will enter the medium, and it will be refracted and reflected, producing the black and white fringe. For this situation, there is two equations. First, the 2nt equal to m plus half lambda, and another is 2nt equal to m lambda. For this equation, they will ask us to find the bright fringe, which is constructive interference, and for the other one, for the dark fringe, which is destructive interference. So n is for the index, which is air equal to 1. Refractive index is 1. For m for how to get the m? First, the first black fringe is 0. Same goes to first bright fringe is equal to 0. The second black is 1. So same goes to the others. To get easier, so we just, if the question asks us for to find the 8 bright fringe, which usually we just minus 8 with 1.
Okay. For the question given for the 2B, and A wedge is illuminated with monochromatic light of wavelength 570 nanometer. Calculate the thickness of the wedge at 8 bright fringe and 4 dark fringe. Okay, for the 8 bright fringe, we know it's a constructive interference. So we use this equation. 2nt equal to m plus half lambda. N is 1 because refractive index for the A. And T, we want to find the thickness. Okay, m is equal to 7 as Daya has said. 8 minus 1 equal to 7 plus half lambda 570 times 10 power of negative 9 because lambda is given in this equation. So we got the T 2.138 times 10 power of negative 6 meter. For the second one, for dark fringe, we use this equation. For the dark fringe, destructive interference 2nt equal to m lambda and destructive A refractive index 1 and m 4 minus 1 3 lambda 570 times 10 of power negative 9. So the thickness is 8.55 times 10 of power negative 7 meters. Thank you.